Okay, let's review the stuff that you need to know before class. The first thing you need to know is some vocabulary here. So we're going to go over this vocabulary in red. And here's the official definition of each of these vocabulary terms for ordered pair, relation, domain, and range. Some of you have probably already heard of these things. And now I'm going to explain them on this video, but the official definition is here. So the first thing is an ordered pair. You've heard of ordered pairs before, I'm sure. Ordered pairs represent, a location on the coordinate grid. So if you forgot what a coordinate grid is, I'll just tell you that this rectangular thing is what we mean by a coordinate grid. And ordered pairs are those pairs of numbers that you see written on that grid. And let me just highlight those for a moment, those pairs of numbers. So each of these is what we call an ordered pair. And you're probably saying, oh yeah, I remember those from elementary school or high school. Each of those are ordered pairs. Let me just put that in yellow so that you know. And what do those ordered pairs do? Those numbers tell us about a particular location on the grid. So here's some locations on the grid highlighted by these dots. And those are locations. Those dots are here. I won't draw the arrows there. And just to remind you about these ordered pairs, these numbers tell us what we do to get to this location. The first number tells us whether we go left or right. The second number tells us whether we go up or down, starting at 0. So just to review that quickly, I know that you know. So to get to this location right here, I go left 1 unit, because that's what the 1 tells us, and I go up 3 units, because the second number from this 0, 0 point. So -1 up 3 takes me to this location. Just to review one other, let's look at this one. How do I get to this location? These numbers tell us. The first number tells us you go right 3 and then up 5/2. What does that look like? Going right 3 from this direction and up 5/2, which is the same as 2.5, and I get to this dot. So those are ordered pairs. Let's go on to the next definition. So the next definition is a relation. A relation is a set of ordered pairs. And so what do we mean by set? Set is more than one object, or one or more, right? Ordered pairs. Well, there you go. This is a relation. Why is this a relation? Because this G is a set of ordered pairs. There they are, 4 of them. And here's another example of a relation. How does it fit the definition? It's a set of ordered pairs, simply, because that's what ordered pairs look like. All right, relations have many different disguises, though. Let's see another type of relation that doesn't look like this, but it still fits the definition. This is also a relation. So how is this a set of ordered pairs? Well, you know why. These are all locations. And what about each of these locations? Each of these locations represents an ordered pair. For instance, this location right here is the ordered pair 2, 4. Or this location right here is the ordered pair 0 left or right, but then up 2. Or this is the ordered pair go left -3 and then up 3. So this is definitely a set of ordered pairs because it's a set of dots. So another way to think of a relation is it's a set of dots or locations on a coordinate grid, because dots represent ordered pairs. All right, let's look at another relation in another disguise. So this is also a relation. How is this a set of ordered pairs? How is this a set of dots? Well, it looks like just one line, but remember, a line, just like our number line, has an infinite number of locations on it. Think of this as just, I'm trying to dot it. This line is really an infinite number of spots, and these spots go on forever. So this relation has an infinite number of ordered pairs, and let's just name some of them. We can't name them all, but let's name some of these dots that are here. Well, here's one location. This is the location 1, 4. Here's another location. This is the location 4, 4. Here's another location. This is the location I went over about -1.5 and then up 4. Let's see, let's find another location. So remember, this line goes on forever. So way out here somewhere, if I go over as far as, say, 100 and come up, there'll be a dot at 100, 4. Even in this direction, remember this line goes on forever, so another location on this line might be something like -5,000 and then 4. Interesting. What's the same about all these? They all are just up 4 because we're ending up at the same line. In any case, this is a relation to a set of ordered pairs, but this is an infinite set of ordered pairs. One more relation disguise. What about this? We already saw this relation. We know that it's a set of ordered pairs. I just want to show you another one by doing something to this. Right now, this is just a finite set of ordered pairs. It's just 1, 2, 3, 4, 5, 6, 7 ordered pairs. But if I change this picture and color in some stuff, suppose I color in this whole V, then this has become an infinite set of ordered pair. There's an infinite number of ordered pairs here. And let's just name a few of them that are in here. Let's say right in here is a location. If I estimate that location, it looks like I went right 2.5, and then I went up, sorry, comma, 3.5. We can draw that better. This location, we could say, is 2.5, comma, 3.5, because those ordered pair numbers could be fractions. Or let's find another one. Let's say this dot right here, I'm just estimating. How far to the left do I have to go? -1, -2, -3, and say 7.5, -3.75. Again, I'm just kind of estimating. And how far up? 1, 2, 3, maybe 3.6. In any case, these are estimates, but there are an infinite number of locations here. There are now an infinite number of ordered pairs in this set, and those set of ordered pairs are called a relation. All right, let's go on to our last two definitions. That's domain and range. So look at the domain definition. I know you can't see it. Now you can see the domain is the set of x values, or first components of a relation, and the range is the set of y values, or the second components of a relation. So let's try to find the domain and the range of this relation that we're looking at here. And to do that, let's kind of label. So this is the ordered pair 2, 4. That's the ordered pair 1, 3. This is the ordered pair 0, 2. This is the ordered pair -1, 1. This one is -2, 2. That one is -3, 3. And this one is -4, 4. So now if I want to tell someone what the domain is, remember that the domain are the x values. So let's look at each of those points or ordered pairs, and we're just going to identify the x values. Here they are. There's the x here, or first component. So these in yellow are the domain, and when I'm writing out this answer for someone, I put it in set notation, and I say that the domain, the set of x values, are the number -4, -3, -2, -1, 0, 1, and 2. That's the domain. Where'd I get them from? From all of these yellow first component values. And if I want to tell someone what the range is, then I'm looking at the second component. So let's highlight that second component with green to keep ourselves color coordinated here. So the range then, oh, I said I was going to do it in green. There it is. So the range is all of the y values. So if I start naming the y values that I have, let's see, I have 4, 3, 2, 1. And then when I get over here to these points, I already have 2, so I don't have to mention again. I've already mentioned 3. I've already mentioned 4. So there's the range. We, of course, could write them in numerical order as 1, 2, 3, 4. But that's the range. Okay, got it. Domain is the x values, range is the y values. Let's see if we could practice that with another example. So again, we're looking for domain, and we're looking for range. There's range. And here is domain. And we want to find the domain and the range for this relation. We already know it's a relation because we've already said that, and we already know that this is a relation that has an infinite number of dots. So it's going to be impossible for us to write out an ordered pair for every single one of these. Like, that would take the rest of our lives because there's an infinite number of ordered pairs. So how are we going to tell someone what the domain and the range is? Well, it's going to be an infinite set. And what exactly will it be? Well, there's going to be a ordered pair like 1, 4. And what are some of the ordered pairs? 2, 4. Let me write them out. Like 1, 4, 2, 4, 3.5, 4. Sorry, 6, 4. Negative 104. What are these? These are all points that are somewhere on this line, right? What other points are on this line? 32, 4, 0.005, 4. So what are we noticing about all of the points here? Well, every single real number in the world, or every single possible x value, will be an x that will show up in these ordered pairs. Look at all these x's. These first components are any number that we could think of is in the domain here. So the domain for this function, it's a tricky concept, is all real numbers. Or if we want to write that in interval notation, that writing is awful. It's from negative infinity to positive infinity, because I could name points forever for every single x value. I could go out to 3 and go up 4. I could go out to 3.1 and go up 4. I can go out to 3.5 and go up 4. I can go out to 4.1 and go up 4, right? All those points are there. Now, what about the range? The range are all of the y values for all the points or all the locations in this relation. And what have we noticed about all of those y's? They're all 4, even though I didn't draw that very well. That's a 4. 4. They're all 4 because we go out and up 4. We go out and up 4, out and up 4. So the range only has one number, and the range number happens to be just the number 4. Okay, good. Are you hanging in there with this domain and range? Let's look at one more example, and this will make you better ready to understand what we do in class tomorrow, probably. Here we go. So let's look at the domain and range. Now, you said, oh, we already found the domain and range of this set, but I'm going to change it. I'm going to change it so that it is this infinite set. So suppose I change this not to just be those 7 dots, but to be all the dots in between. Now let's see if we can look at the domain and the range of this set now. So what's the domain? The domain is all of the x values. Well, if I look at this purple line, there's an awful lot of x values. And this you might not understand now, but I'm going to put it out there, and then we'll talk about it more in class. The domain for this function are all of the x values from here to here. And what are these x values exactly, or what is that from here to here? Let me put those numbers in. This is the number -4, and this is the number 2, and all of these values, and I'll explain this more in class, but from -4 to 2, I'll at least just get you started and say that there's a point up here that has each of these x coordinates.